Okay, my next project here is going to be a device under test current limiter, because I work on all kinds of things that have shorts in them and they draw a lot of current, and it would be nice to know that before I plug it in and start blowing fuses. These are also called dim bulb testers, so unless if you have wiring and high voltage experience, don't try to do this. But basically the input's going to come either from an isolation transformer or a variac. Got your line, got your neutral, double pole single throw switch. Going to have an indicator here across the line. Have the ability to put up to 3 bulbs in parallel. These are the sockets that I'm using, and I'm using appliance bulbs because you get a lot of power in a very small form factor. So I'm going to fit 3 of these across the back. 3 of these across the back of the box. I used a fairly small footprint box, and I plan on using analog meters, voltmeter, and an ammeter. And the way that's going to hook up is the ammeter is going to be in series, and the voltmeter is going to be across the load. Then, depending upon whether I use the 2 or 3 wire configuration, I do have a ground with a pass-through switch, so you can either use it in 2 wire configuration with no ground, 3 wire with a ground, or you can disconnect the ground, which of course makes potentially for a deadly situation. So you got to know what you're doing there, and you got to take the right precautions, but that is the way I'm going to wire it up. So on the front panel here, I'm going to have my switches. I have my on-off switch with an indicator, and that is the part number. And then I have polarized jack. Input's going to probably go over there. Let's see if I can get it to focus here. There it is. These are the light bulb sockets. That's the voltmeter. That's the ammeter. These are the appliance bulbs, oven light bulbs. So they're pretty heavy duty, plus they're high power. 3 of those. And then on the right hand side of the box, I use a heavy duty industrial type socket. And then on the front is going to be the switches. And the switches are isolated, and they also are waterproof and have a rubber cover that goes over the metal switch, so you don't actually touch them. So you got some isolation there. So let's start punching some holes in the box and laying it out and see how it moves along. Okay, so roughly that's what the top's going to look like. Voltmeter on the left, ammeter on the right, 3 bulbs on the top. That's the rough layout. Okay, so I templated the box. Not perfect layout, but gives us a pretty good idea where everything's going. Lights are going to go here. Meters are going to go here. That goes into the AC in goes there. Switches are going to go here. On off on the left. The 3 lamps in parallel plus a bypass on the lamps. The ground bypass. And then our outlet socket is going to go right there. So I'm going to punch some holes in here. Take the plastic off, and then start doing some cutting. Okay, got the holes punched out in the box, kind of like index holes. On the top there, I had to take one of those ribs out to get the on-off label up high enough so I could fit 4 on the front. Okay, I just cut out the holes for the light sockets, and those fit in there perfectly. And that's what I used. It's a hole saw, 1.5 inch hole saw, 1/4 inch pilot bit. Okay, so now we got the cutouts for the voltmeter and the ammeter, and that was a 2.5 and a 3 inch hole saw. Okay, so just mocking this up here for a fitment test. The meters fit perfectly. The bulbs are going to work perfectly. It's spaced out just right. Let's get to work and get all these knobs and the input AC socket and the output socket in, and then we'll get to wiring this thing up. Okay, to drill the holes for the controls, the buttons, the switches, I'm using a step bit. So for the on-off indicator, that's got to be right around 16 millimeters. Okay, so the on-off button's in. Let's get to the rest. Okay, to make the cutout for the duplex socket, I just drill a bunch of holes, then I use the drill bit to open those up, and then I file it to finish. Okay, so there you can see one side's done. Just move the bit around and use the bit to kind of drill it out. And now we're off to the next one. Okay, so there we go with a little bit of filing. We'll test fit it and make some final adjustments here. Blow this whole thing out and start assembling it. Okay, so there we are. Duplex socket is fitted. Last thing we have is the AC input jack. Okay, so this is roughly what it looks like. There's your front panel controls, the on-off, 3 loads, load bypass, ground bypass, voltmeter, ammeter. We've got our duplex socket outlet on the side. We got our inlet socket on this side. We got the voltmeter and the ammeter, and there's our incandescent loads. I ended up changing on-off switches. This is the one I'm going to be using. It's a latched double pull, double throw illuminated, and it's going to fit in that hole. I need to enlarge it a little bit so this one will fit. This is the power cord that I picked up, and all these parts that I'm showing you, I basically got everything off of Amazon. So when dealing with the C13, C14 connectors, sometimes it can be a little confusing what the wiring designation actually is. So there's one quick way to verify that. So if you look at the power socket, the small hole, the one on the right, that is hot or active, depending upon what part of the world you're in. The big one's neutral, and the bottom one is ground. So if you get no meter and go to your power cable. So looking at the 3-prong connector, the one on the top right is the one that goes to the small outlet side, and then it's this one that plugs into the C14. And if there's ever any question, you can see on the end of the power cable connector, it's actually got the designation stamped right in it. It's very small, but it is actually marked line, neutral, and ground. Okay, so the tester's done. I have it plugged in, powered up. I checked it out on the Variac first, and it is good. I ohmed it all out. Everything's happy. I have a line tester in the socket. And while you can't read it, the voltage is correct. 2 lights on means it's wired properly. It's important to remember this box provides no electrical isolation. To get isolation, you need to use an isolation transformer. So you use an isolation transformer, then a Variac, that plugs into this, and then the device under test plugs in over here. And if you're using a plug-in oscilloscope that's connected to ground, you still have to be extremely careful using a plug-in oscilloscope. So I only use my battery-powered scope, and I only use one probe. So that's the safest thing to do if you don't know exactly what you're doing and you don't test everything out, is to use a battery-powered scope. Bear in mind, I built this for entertainment purposes only, not for anybody else to build it, but this is what it looks like, and I'll show you what the wiring looks like inside. And you can see we've got 120 volts or 115 volts there. Of course, the ammeter is showing a minimal load because all we have is the socket tester in there. Okay, unit's powered down. This is what the inside wiring looks like. I did not go through the detail of all that because I'm not showing you how to build this box. I'm showing you how I built my box. So the wiring's kind of complex, but it's done and it works. Okay, so I have the unit turned on. I have an amplifier plugged into it. As you can see, the bulbs are lit up very dim, which means the amplifier is not shorted. It's only drawing a couple amps here. But if it was shorted, those bulbs would be lit up super bright and it would be protecting the amplifier because the vast majority of the current would be flowing through these bulbs. So that's it. It's done. Hope you enjoyed the video. See you later.